Hello, everyone, and welcome to this month's Python Exchange. My name is Cameron Riddell, and I'm very excited to be joined by all of you in our audience. This week, we have a very special guest, Gijs, who will share their thoughts on the Parquet file format and how Polars has optimized their Parquet reader over time, keeping it as blazingly fast as it claims to be. Gijs is a software engineer and open source maintainer at Polars. He has a master's degree in cybersecurity and has worked on hardware testing and simulation. Of course, at Polar, he spends his time improving the Parquet read and write performance, which will be our primary topic of today. As for our host panelists, you'll see some familiar faces like Dan Allen, James Powell, and of course myself. So Dan and James, why don't you go ahead and give everyone a wave? And with our introductions out of the way, I'd like to turn over our metaphorical microphone to Gijs to dive into Parquet read optimization. So Gijs, take it over.
Yeah, so let's get this presentation on there. So welcome everyone. My name is Gijs. I have been spending a large chunk of my last year actually improving the performance of the Parquet reader at Polars. So a bit about Polars and about me. So Polars is a very fast data frame library, and it is known for being kind of one of the fastest on a single machine. And with that comes kind of with the territory comes Parquet. Parquet is this file format that is widely used in data analytics pipelines, and it's a columnar file format that has become the standard as a backing file format for example, Iceberg, Delta Lake, but also just a standalone file format for storing data sets. So why would you even care about storing, optimizing Parquet reading performance, right? So I did a bit of a benchmark a few days ago because I had done this benchmark already a year ago, but I wanted to see now after all of the optimizations I did, what is still the percentage of the time that we spend on Parquet reading in our benchmark suite. And actually, it's still more than half of the time that we're spending in our query time just reading Parquet files. And this is completely insane. You need to understand that this is a very big point where you should be focusing your time if you want to actually do things fast, right? So I want to talk about kind of 5 things today, 5 techniques that we employed and that we looked at when doing optimization for Parquet. We're going to start off a bit simpler and we're going to go into more and more advanced techniques. Um, and I'll try to keep it a bit low level, but it might get a bit technical at points. And then we can slowly get the understanding up, right? So let's start with compression. And I want to kind of start with how a Parquet file looks. So Parquet is a hierarchical format. So you have row groups that said, okay, we have this many rows in this row group, and you might have any number of row groups. So if you have a file that represents a million rows, any given row group might only have, let's say, 100,000 lines, and then you have 100,000 rows, and then you have 10 row groups. So in these row groups, per column chunk, or per column, you have one column chunk. So all the data for one column will be saved in the same space, which basically means that your data format is a columnar data format. So that means that accessing data for one specific column is very fast. And if you want data for one specific column, you don't need to scan through all of the data. This is, for example, the case with CSV or JSON, where you will need to look through all of the data of all of the rows just to get to a specific data point for a specific column. So next to these row groups, you also have some metadata that we will look at a bit later. But one important point here is you might, when you start off reading, wanting to optimize Parquet read performance, is you might initially make the observation, okay, reading files from disks, especially big files, or even reading from the network like S3 or Azure, the speed that you read data from your disk or from the network is much slower than your CPU can operate at. So you might want to trade a tiny bit of time that your CPU operates for the time that you're spent loading data. And this is basically what compression does, right? So I looked at this. So we start off at for our benchmarking suite, the total size of all our files is 6.5 gigabytes, and we can do some compression on these files, and then it basically shrinks by roughly half, or a tiny bit more than half of the file size. And you can see that indeed, because our CPU is faster and we can just let it do some decompression, that's fine. The runtime actually goes down by quite a lot. And we do have to spend some time on decompression here, but that's completely fine because overall our runtime went down. And this effect is even more extreme when you look at, for example, loading from the network, where loading large amounts of data from the network is even slower than just loading from a disk. So that is kind of the first one. Let us look at maybe a bit more Parquet specific one, which is these dictionary pages, right? So you might have already noticed you have per column chunk, you have pages, and each page might store a certain amount of values per column. And you can actually only load a few. You can only load one or a few pages if you only need data from those pages, right? So if you only need the first 10 rows, like you might do like, oh, give me a limit of 10 or give me the head of the data frame. You only need to load the first data page. Similarly, you also have other kinds of pages, and specifically you have this kind of special page, which is a dictionary page, which is for dictionary encoding. Parquet, for every kind of data type, has all these kind of encodings, and I think by far the most important one is the dictionary encoding, which basically stores at the beginning in this dictionary page, it will store all the unique values that you might want to represent. And then in the data page, instead of over and over referencing the same data again, it will just give offsets into the dictionary page. And this is a very big optimization for low cardinality data. So if you, for example, have a category like a country or a city where usually you have relatively low cardinality within your data set, you can just put all your cities or all your countries in your dictionary page and then reference them later on in your data page. And Parquet has two kind of optimizations on top of this, right? So it has bit packing, where basically if you have a bunch of values, here we have all country codes, and we have them kind of in sort of random order. What we will do is indeed we will put them into like a dictionary. So all unique values are in a dictionary, and then we will reference them by their offset into the dictionary, right? And what Parquet actually does, since we know the amount of values in the dictionary already, we can, instead of storing this in like a static 32 bits per index or 16 bits per index, you can just push them all together because we only need 4 bits to represent these 9 different dictionary keys. So this number here, 16 bits, so it takes 16 bits to represent one of these country codes, to 4 bits, this is kind of arbitrary, right? So like you can get a very big reduction, but the reduction can be kind of arbitrary. The second optimization that dictionary pages allow you to do is very standard technique in general compression methods, which is run length encoding. So here we have like a country code that's repeated a bunch of times and another country code that's also repeated a bunch of times. And instead of repeatedly encoding the same number, we can just say repeat the first country code 42 times and then repeat the second country code 24 times. And this basically allows us to do kind of arbitrary compression. And for data sets that are sorted or that are grouped, this can lead to massive, massive, massive reductions. So given that, let's move on to somewhat more of the query level optimization. So now we talked a bit about like Parquet and coding level optimizations. Let's look a bit more at the query level optimizations, right? So Polars and many SQL things that also look at Parquet, they're query engines. And when query engines look at data, they don't just read the whole file at once. They will be smart about what data they actually need to read. And this usually falls into two categories. So you have predicate pushdown, and that basically asks the question, what rows are we focusing on? So this might be indeed like a slice, like you only want the first 10 rows, or you only want the last 10 rows, or you want, or it might be a predicate. So here we give the example, you want everyone that's 18 or older. And then the second one, you have projection pushdown. So what columns are we actually focusing on? So this is like a select statement where you only select certain columns. And this might also happen implicitly. If you just don't use certain columns, most query engines will only load the columns that you actually used. And I want you to notice that since how Parquet files are structured, you have the column chunks already split up. This second one is basically for free. We can just look at the column chunks that we want, that we need, and the rest we can just completely ignore. But the predicate pushdown is a lot more complex. And actually, this is what we will be focusing on for the remainder of this talk, because there's a lot that can be done here. So the first one that we are talking about is row group statistics, right? So I already mentioned that we have this kind of metadata at the bottom of this file. And what that metadata includes is it basically includes statistics about the columns for every row group. So these statistics include, like, let's say, the minimum value, the maximum value, how many missing values there are, like nulls or nones. And with that, we can look, for example, at a predicate. Like, let's say the predicate was given, okay, the age needs to be, someone needs to be 18 or older. We can kind of translate that into a similar kind of predicate, but that operates on the statistics itself. So we are given here the predicate ages 18 or older, which basically means that we can skip the row group if the statistics say that the maximum age in that row group is 17 or is 17 or younger. So given that kind of expression, we can then establish some kind of mask or like a true false vector that says, okay, you can skip this, or you can't skip this one, you can skip this one, you can skip this one, you can't skip this one. And it basically allows us to cut out loading entire row groups, which is a big optimization. Like, the best kind of optimization is not doing any kind of work. And that is basically what this will allow you to do. So basically what that looks like is you can just completely ignore parts of your file, which is a big win. And I also want you to understand that these predicates can get kind of arbitrarily complex. So you can even combine predicates that include multiple columns. So if you have like an equality predicate and a inequality predicate, you can turn that into like a statistics evaluator that gets quite large. And actually, this is how it looks in actual implementations. These are not even the whole predicates. You need to take into account null counts and this kind of stuff. And they can get very large very quickly, but it can be done for arbitrary expressions. So given that, let's push it a tiny bit further. And let's look at one optimization that Polars actually specifically did quite a lot on, which is what we call pre-filtering. So normally how it works when you have these predicate columns is you load all your data of the projection, then you do your pruning. So you only load the data for the things that you didn't prune, right? So with your row group statistics, and then you do just your normal predicate, right? You don't know anything else about that data, so you just do your normal predicate. But you can notice about this that that's actually not necessary. Like, if we are doing this age is greater than 17 predicate again, for that predicate to be evaluated, we only need the age column. So we get this age column, then we evaluate the predicate. We look, okay, where is the age bigger than, I don't know, 17? And then instead of just loading all the data from the other column and then filtering afterwards, we can filter while we're reading. And this is actually like a pruning with perfect knowledge, right? So we know exactly what rows we want, and we only load those rows. And this might mean that you can skip again entire row groups, or again in again data pages, which is again a lot of data that you don't have to load. It's a lot of computation that you don't have to do. And again, it's this optimization of just doing less work. So we can build on this with even two kind of extensions on this. So we can, while we're loading the predicate columns, we can already do a tiny bit of filtering on them. So if we have, for example, a predicate like this, like the age is bigger than 17 and the country is from the US, we can translate that into two separate expressions. So one where we ask, okay, the age is bigger than 17 for this age, and then one where we ask, okay, the country is equal to the US. And while we're reading the age column, we apply this predicate, and while we're reading the country column, we apply this predicate. So at both stages, we won't do perfect filtering, right? Like we won't be doing both predicates at once, but afterwards we will have loaded less data, probably, for both columns, which will again be less work. It will allow us to do a lot of filtering and a lot, especially for equality predicates, it will allow us to do a lot less work. And then the second one is we can notice one more thing, which is that for some columns, they might not be actually in our projection, right? So we might not need them afterwards, but we only use them in our predicate. So for example, if you have this predicate here on the left, the age is bigger than 17 and the country is equal to US, well, now in your data frame or in your output, the country is always going to be equal to the US. So you're very rare that you are doing something interesting with that country column from that point on, right? So why would you even include it in your data frame? There's very little reason that you might be using it. So why would you even materialize it, or why would you even want to load it? You can only just look, okay, when is this predicate true, instead of load the data and filter on that. So given that, we kind of want to move to the last thing that we focus on, and actually we have not landed this yet in Polars itself, but we are working on this. So page level statistics. So we already saw that we can kind of prune entire row groups out of from loading the entire row groups, but we are not doing that yet in general based on statistics with the data pages. And there's quite a good reason for that. And that's because the data pages don't have to be the same amount of values between the pages, right? They might be misaligned. And originally we thought, okay, well, we have these column predicates already. They're like kind of shrunken down versions of these. And we can then do kind of a shrunken down version of this row group statistic evaluation, and will be good. But actually you can do something much smarter, which is that, let's say you have your age bigger than 17 and country is equal to US, a predicate again. You can look at your pages. They might have different amount of values, like illustrated here by the height. You can take those, like at every border, you can basically just make a group and then load the statistics for each data page, depending on what data page you are at that point. Then again, you can, with kind of a slice pushdown now, you can basically say, okay, we only need to load this, we only need to load this, and it basically becomes the same problem that it was for the row groups, but now for your data pages as well. And this again allows you to save a lot of work that you needed to do. And actually it will allow you to save even like decompressions, which also is a big part of your time. So that was kind of all the things I wanted to talk about. I think it went kind of fast, but that's fine. I want to kind of end up with a few take-home messages, right? So read times are a surprisingly big part of your data pipelines usually. There are some people who might think otherwise, but from all the places that I've seen, they are quite a big part of your pipeline. If you want to actually take the speed of your pipeline seriously and save costs or save compute, it means seriously thinking about how you store your data and how you load your data. Secondly, Parquet actually has many different ways to represent the same data. Like if you load it, it will come out as exactly the same data frame or exactly the same table, but the encodings in the backend and the metadata might be completely different. And those are actually very important for the performance of your query, or like just how long it will take to load your data. And the third point is Parquet readers are really not the same. Like some support certain features, some don't support features. Some are actually much faster than other ones. And I did a lot of comparisons, and you can really see that at certain things, some are just so fast, and at other things they are all of a sudden very slow. And then there's big differences between Parquet readers. So that was kind of what I wanted to talk about. Yeah, thank you very much. And if you have any questions, I'm 100% here.
Excellent. Thank you so much, Gijs. If you in the audience have any questions, do feel free to submit your questions via the Q&A. If you simply want to chat, talk, and hear what our host panelists have to think about a particular topic, you can go ahead and use that chat widget. But this will also be our time for our host panelists to ask any questions to Gijs about what was just said or Parquet file specification in general, because I know you're a wealth of knowledge for that. Before we jump into the questions, though, I did want to give our panelists an opportunity just to briefly introduce themselves in a sentence or two. So we'll start with James. James, can you tell us just a little bit about your background and the questions you're excited to ask?
Hi, everybody. My name is James Powell. I want to thank our guest panelists for a fantastic talk about Parquet. And one big question I'd have for them is how many more years does Parquet have? I know there's tools like Nimble and others that are starting to nip at its heels. How much longer do we have to deal with Parquet before it's on to the next thing?
Uh, I don't want to make any predictions, honestly, but basically, I don't see it going anywhere anytime soon. Like it has now become basically it's not the definite backend. Like they try to keep the door open, but like Iceberg and Delta Lake, which have become way more used, are relying on Parquet as well. And the amount of time that gets spent in these file formats and optimizing like just raw reading speed is a lot of time. Like if something wants to come in and replace it, it needs to have serious benefits over Parquet. And like Parquet definitely has its flaws. It's definitely not perfect, but at the moment I don't see anything that has like, okay, it's like 500% better, whereas like the value is so much higher that it's of like putting out of the way like how much time it would need to be spent to optimize it again.
Very interesting. Hopefully, Parquet has the same kind of staying power that a CSV file has, because although they're not great, they've been around and they're probably going to still be around. Next up, I'd like to let Dan introduce themselves. Dan, if you want to just say a quick sentence about who you are, what you do.
Sure. Dan Allen, and I lead the data engineering group at NSLS2 at Brookhaven. This was a very data engineering-y talk. This is aimed straight at me, and it's my favorite one I've seen in a while. So thanks for dropping by. I had the same reaction to James' question. You might as well ask, when will we be done with the CSV? We have at least one user of the spec file format on this call, which is our own bespoke text format for tabular data that kind of, you might even say predates the CSV, at least being used in a widespread way. So we know legacy formats here. I'm sure we'll be we'll be using Parquet for a long time. I was going to ask, it's not too different than James' question. What's your wish list for these new formats as you're trying to optimize Parquet? What are you wishing that it would write down to let you take more optimizations?
That is a very good question. So for sure, like, okay, one of the concrete things that I ran into recently, for example, was as a query engine, it's very interesting when data is sorted, like how your data is sorted. Like you can do a lot of optimizations if your data is sorted in a specific way. And actually, a lot of people will sort their data when they're storing it in a specific way.
Yep.
But they have kind of support for this, but it's on the row group level. And usually you actually want to know this on a file level, right? Like you want to, while you're loading your entire file, I want to have the guarantee that while what I'm loading is sorted in a specific way.
Mm-hmm.
I'm like going through my mind, like, is this a good thing to propose to the Parquet standard to add? But in the future, other file formats like for sure need to support something like this. Like these, basically, there's a lot of things that query engines can do that would be very interesting for these file formats to include.
Thanks.
Excellent. All right, and last but certainly not least, joining us at this late hour for themselves is Marco Gorelli. Marco, thank you so much for being able to join us. Do you want to go ahead and introduce yourself in a sentence or two?
Okay, sure. Hello, everybody. Was not expecting to be guest panelist here, but thanks, Cam, for inviting me last minute. Usually on Wednesday evenings, I'm at the Irish pub playing music, but it got cancelled this week, which is just as good because I was really bummed out that I was not going to be able to attend Gijs's presentation, but glad I could make it. So yeah, I work at a company called Quantsite Labs, which does a bunch of open source things, and contribute to Polars as a volunteer, but in areas that haven't really had any overlap with today's presentation. So this was, yeah, very, very interesting to me. Interested to ask about IO plugins later.
Excellent. And with that out of the way, we will officially open up the Q&A now. So if you do have a question there in the audience, feel free to submit it. And I'll open this up to our host panelists if you have any other questions that you want to ask Gijs.
I'll jump in with another one. You mentioned that you had tested various Parquet readers and found sometimes surprising things that they were good at or optimizations that they weren't taking. Did you write that down? Is there a spicy blog post on comparing Parquet readers that I can check out?
It's always risky calling out specific because
Yeah.
you just know that as soon as you write it down, like I will do the exact same thing. It's like people will say something, and then the people who know exactly what's going on, they will come out and say like, no. If you
Yeah.
just look
Yeah.
at it like this, but yeah, in general, like we were like one of the targets we had very early on was like to be kind of on par with DuckDB. So we spent a lot of time like evaluating against DuckDB, and we were like, I think around November we like had most of the test files we were like up to par with DuckDB, and then we kind of went beyond them, like we went a bit faster than them. We were like so happy, and then I think recently they caught up again, and we also did some stuff again. So I think we're now probably again like equally fast in general. But yeah, like I think also like data fusion also is like they are insanely fast, and they can use basically all the kind of features that Parquet has. That's also very impressive. I think we have spent a lot of more time just like optimizing raw reading performance. Like actually, let's say you just want to load all the data just like go as fast as possible. We spend a lot of time on that. And Data Fusion has spent a lot of time on just implementing all these kind of pruning techniques very efficiently. But they've spent, I think, a bit less time on actually just like the raw, like sim-dized, vectorized reading performance.
Since we have plenty of time, I'm going to smuggle a follow-up question in here then. So at the very beginning, you mentioned that compression is almost always a good idea because you can keep the CPU busy in parallel to the disk or network.
Yeah.
What are the circumstances where it would make sense to use a memory mapped arrow file instead of our Parquet file? Is that only when you're actively working on the data from multiple languages at the same time, which seems to be Arrow's core use case, or?
No, actually, so even no compression on Parquet makes quite a lot of sense sometimes. Parquet decompression, like I did not include that, but I did some benchmark as well, and like compression is quite a big part of your time now. Like if you actually compress your data, it's going to be a big part of your runtime. And there are certain things that just don't need to be compressed. Like the dictionary encoding is basically a compression, right? Like that is just basically what your compressor is going to do anyway. So you might want to say, okay, I'm not going to compress that in general.
That makes sense.
And I think so. The main version of Parquet that people use is Parquet 1.0. There is a 2.0 that I think most readers can read, but they don't usually write it out. And that also supports disabling compression per page. And there I can 100% imagine as well that like for specific pages, you don't really care that you don't really care and you can just disable it. But for 1.0, this is not possible. And that's the one that most readers or most writers will write out.
Thanks.
So I have a question that goes in kind of the other direction. There's a lot of complexity behind these file formats, which you illustrated here, some of which is only really exposed to people who write the tools themselves. Other complexity is exposed to the end users. And I think a lot of people joining us on this call are people who work with scientific end users who honestly don't want to navigate the 8 or 9 different keyword arguments for write Parquet and Polars. They don't know which compression level to use. They don't know whether the right statistics or not.
Yeah.
If you had a scientific user come to you and say, very quickly, I need to decide what format to use for my data, what are the 3 questions that you ask them to be able to make the best possible guess? What are the 3 things that you say, okay, if I know the answer to these 3, I can get kind of close to something good for you?
I think, first of all, what are you going to be querying over, right? Like, are you going to be, do you have like some primary key that you are you like going to be joining on, I don't know, like the user ID or the name, or is it, and then maybe the second one, is it sorted in a specific way? Like, is there a certain structure to certain columns that you can start to exploit? And in both those cases, you need to focus on encoding those in a very efficient way, and maybe even saying, okay, I don't want to compress those columns if they already have some structure there. And then third is, I think, do you have some kind of like blob storage, like something that is huge, like that is going to be, I don't know, like entire text files? Like I even had someone message me who basically like stored a CSV file in every row of a column. Like it was kind of insane, but that is it's a use case. And
I've
for
seen
those
worse.
things, yeah, like you want to enable maximum compression for that. Like if you do this, it's gonna absolutely kill performance on that column, and you need to make sure that like the compression for that is as high as possible.
Do you think that storage is more important for the typical user than, for example, simplicity or speed of reading or speed of writing?
That's a good question. So it kind of depends. I think a lot of use cases are you write once and you read a lot of times. And in that case, you usually trade writing speed for reading speed a tiny bit. Like you can do a lot of optimizations that just in general improve performance, but usually, like for example, if you do a higher level compression, it usually means that your writing speed is going to be very slow. But if you have some data set that you're indeed just writing once and then reading a bunch of times, maybe it's worth to do the slower writing speed. But indeed, if you have some pipeline that it writes to an intermediate file, then gets read again and writes again and reads again, in these kind of cases, yeah, you want to also think about write performance a lot, right? Because it's going to be a big part of your, like I didn't include it here because this one was specifically about read performance, but I also worked a bit on write performance, and that's also can be quite slow.
Excellent. Well, that's the previous answer. I had a question here that I was going to ask about what's the oddest thing you've seen somebody do with a Parquet file, but I think you've addressed that. We had a question come in through the Q&A widget here, and it asks, practically speaking, how would you suggest optimizing reading and writing Parquet files with Polars? Are there any function arguments that one should play around with? And this is going to be a little bit counter to James's question, where he was asking, what are the things you should stay away from? Whereas this question's asking, what are like the 3 options I should probably be aware of with Polars write Parquet or read Parquet?
I actually, at the moment, I don't think I can give a very good answer for that. Like I have been working a lot now also. So I think I've gotten to a point where I'm quite satisfied. Like we're never finished with this reader, but like I'm quite satisfied with the reader. But now we need to, I think, also become something that where the writer is very powerful. Like we cannot write all these encodings. We are working on actually like giving you full customization field to field. Like, okay, what encoding am I going to use? Am I going to do this compression? Am I going to add some kind of metadata here? Yes or no? And I think this is yeah, this is, I think I can't really give a good answer for that at the moment, honestly.
Of course, there's always the documentation. We'll go ahead and post a link in the chat to that so you can see around with what's up with Polars read Parquet. Now, you mentioned earlier about there's a trade-off about the write performance and the read performance. I was curious about this as you were speaking earlier. A lot of the optimizations that you pointed out were focused on kind of row group or page level statistics. I'm curious, do the calculation of those statistics, is that a large overhead during write, or is it a small overhead during write?
So there are expensive statistics and there are kind of cheap statistics. So the minimum value, maximum value is actually quite cheap. You have also distinct count, which like I think for a lot of people is just unique, like unique count. This is very expensive. Like, and I also am not really sure. Like, we don't use it for any kind of pruning, as far as I'm aware. I also am not aware of anyone that actually writes it by default, because it's just so expensive to calculate. Maybe I'm wrong on that, but like I have not seen anyone who does that. But yeah. It like okay, so maybe to answer the question, so there is definitely an overhead. Like we can disable it, especially page level statistics can get also very big, like storage wise. But I think for row groups, it's almost always going to be worth to write.
That makes sense.
Should we pull out of the chat? I see, in addition to the, yeah.
Yes. So the next question coming to us from the chat is asking about Parquet supported metadata. So I know it stores things like the data types and things like that for the column, but is there kind of arbitrary user-defined metadata? Like, can I define the units for a particular column?
Yeah, you can 100% add like it kind of has like a key value storage that you can supply. I think we even support like a callback that basically just gives you like you can give a lambda, Python lambda, and it will write that like it will write the value into the Parquet metadata.
In Arrow, the metadata is sort of per table, not explicitly per column. So if you want to put column metadata in, you have to sort of have some user-defined convention like a key values that match the column names or something. Is it the same in Parquet, or does Parquet give you first-class column level metadata?
So actually, like Arrow has both nowadays, where it
Ah.
also has metadata for columns.
Okay, didn't know that.
And actually, so Parquet and Arrow are kind of interleaved, but not really. Where if you load from Arrow, it will just if you write something from Arrow, it will just store the Arrow schema as base 64 in the metadata, which is kind of a crazy way to do it, but it works very well. And there it will also save the actual Arrow column key value metadata. But like apart from that, Parquet also has this separate key value metadata.
Thanks.
I have a question in two parts, and it's a somewhat complex question. But in my extraordinarily limited experience, when you talk to a beamline scientist and you ask them if they're interested in columnar data, they'll typically say no. They don't really have that much interest in polars or pandas. They're more interested in NumPy and Xarray because they view their data as being multi-dimensional image data.
Yeah.
But as I'm aware, when the detectors start moving towards being, to use a very broad term, event-driven, then this becomes more like time series data. Is that not right, Dan?
It's true.
So in the beamline universe, is it the case that there is now an uptick of interest in columnar data analysis tools, since that's what the event-driven detector looks a little bit more like? And what do you need out of a file format like Parquet or out of a columnar data format to actually support the analyses that you want to do on something that looks like time series stuff, but everybody thinks of as being an image?
I am honestly not 100%. Like I don't really come from this world. Like
I think Dan can fill in some
yeah,
gaps
Dan
here
can
because he's
maybe
very
answer this
familiar with
better.
this.
Yeah.
Sure. I'm giving it a little thought here. So the so first of all, we should say many of the techniques that we use result in spectra, and spectral data are fairly naturally tabular. That data also tends to be small batch artisanal data, kilobyte scale data or megabyte scale data. So it's not being
CSV.
stressed for performance. If you're lucky. But we also have these imaging detectors. Typically, they've been giving us something that we would call a video, right? A time series of images. But as the detector rates go up and the number of photons that we get asymptotes, we start to get very, very sparse images, and the detectors are giving them to us as a excuse me, a time series of events that are naturally tabular. I guess one of the things that we'd be interested in is a format or a storage that lets us look at the data as it's streaming in. So something like a database with atomicity, because we want to know how the experiment is going before the file is closed, before the thing is done.
For the high fidelity detector, do you get the signals synchronously or asynchronously? Do you get them in like snapshots, or do you get this photon and then a microsecond later this photon bit by bit, and then you have to reconstruct the image?
The second thing.
No.
I have to think really carefully about that. It might depend on the detector, but we're getting readouts of charge on a pixel that has exceeded a threshold. And from those events, we figure out, oh, these 3 pixels that are near each other all received some charge around the same time. That was probably due to a single photon. So there's clustering, and there's the kinds of distance-based algorithms that lead you to a KD tree and these kinds of things, which don't show up in data science so much.
I can imagine that there's kind of like 2 phases to this, right? So
Yeah.
there will be like a kind of a cleanup phase where you really interpret what your sensors say, and you interpret what data is coming in, and then you make it into something that is more cleaned up, that is more that you can handle with more traditional tools like query engines and yeah.
That's exactly right. You're getting like a machine level readout of what happened on the detector, and you're transforming that into a scientifically meaningful readout of what we think the physics was, going from charge on the detector to photon that we think struck it. And once you get to the photon, now you're into, exactly as you said, something that the mainstream data science tools deal with well.
We had another question in the Q&A here asking about reading Parquet files from GCS or Google Cloud Storage, I'm assuming. And it's asking, does Polars do anything to speed up the reading from an object store? And 2, is there any options or structure that one should impart on their Parquet file if they're going to be storing it in GCS?
So yeah, there's two elements for here, right? So what do we do to speed up from object stores? So I already said for network, it's this file size element is even more extreme than for just local files. So you want to make sure that your data is as small as possible, and you want to prune as much data as possible. And there is, so maybe let me start with the second part. How you want to structure your data here usually is you want to add some kind of overarching structure to your files. So this might be Hive storage, or like more modernly, you might have like Iceberg or Delta Lake, that basically allows you to skip even more parts of your data than Parquet itself would even allow. And it would basically allow reading even less data. What do we do specifically to speed up object stores? So there's another kind of more technical part to reading from the network. And this is not something I worked on myself, like someone else in my team worked on this a lot, and they explained it to me that basically you want sending network requests, you want to send as little network requests as possible. And usually you will actually start, if you send a lot of network requests, the network request will get blocked at some point. So you want to send a few network requests that actually load a big range of data. And this sometimes kind of conflicts, because doing one big load you might want to do one big load for your entire column chunk, for example. But if you're then going to be pruning on that data afterwards, then you already loaded the data. So a big part of your performance is already gone. And this is kind of a balance you need to strike of like, okay, how many network requests do I want to send out versus how much am I going to be expecting to prune data?
That makes a lot of sense. So you need to, any guidance on how to find that balance?
Yeah, so usually we do that, or like the engine itself decides on this.
Mm-hmm.
And at the moment, it is basically, we usually now err in the direction of we just load the column chunk for you, and then we will do the pruning afterwards.
Mm-hmm.
This kind of also still stems a tiny bit from the time where we were not as good at pruning data. And maybe now that needs to be reevaluated. But as a user, you don't have that much control over this besides actually splitting the file yourself or writing smaller row groups yourself.
Mm-hmm. That makes sense. So again, that write optimization, being aware of it is very important. Margot, I know you said you had a question about Polars IO plugins. Did you want to go ahead and ask that?
Yeah, sure. Not really sure if this is well formulated or makes sense, but tried to put something together. So Polars does support I/O plugins, which allow people to define their own functions for reading from different sources, and there is the option to pass down predicates to and column filters. Is there anything more that could be exposed as arguments in plugins that could allow people to do different kinds of optimizations? Like I was thinking of this specifically because I saw recently that DuckDB have introduced a way to go directly from DuckDB relation to Polars lazy frame by using this IO plugins mechanism. So if your DuckDB relation was starting from a Parquet file, is there a way to make sure that they get the information they need?
Yeah, so this is really interesting. We've been thinking a lot about these IO, like they actually are getting a lot of use, and it's really cool to see. There's also kind of a tiny bit of a problem with the IO plugins in that they very much leak our kind of internal APIs, and that's why they're still unstable. And we've been thinking a bit about how we want to deal with this. But yeah, so maybe to go back a tiny bit more to what your question was, like, can we expose more data? Yes, like basically there's a lot of things that an IO plugin might know about your data. Like, for example, how is your data sorted? Or do you have statistics about your data that might be interesting to us? But another thing that might be interesting to IO plugins is it takes actually a lot of time and it's quite complex to optimize for reading multiple files. Like if you have Hive partitioning, or if you have if you're just reading a bunch of files with a bunch of statistics, it might be interesting for us to expose to them, okay, here's this function you can give us to open a file, and we will do all the rest of the handling of like reading multiple files and like spinning up multiple, like doing all the multi-threading and doing everything. The going back a bit again, so there's a bunch of stuff we can do, and I get very enthusiastic when I talk about this because it's really cool to see everything that people are doing with it. We do need to be a bit careful with how we expose this, because we did it, like the IO plugins now are super powerful, but they're very hard for us to support because they expose these internals at the moment that we are it's very difficult for us to make stable.
Sure, thanks.
Well, I have one or two more questions actually, and this is going to pull us back to a little bit bigger picture, how the environment has changed over time. Now, I know that Polars is not using PyArrow under the hood, so I'm not trying to say that or mention that, but I am curious because I feel like 2 years ago we had Parquet readers that were separate, independent kind of Python packages. And now I think Fast Parquet has been kind of absorbed into PyArrow, if I'm not mistaken. Somebody correct me there. But I'm curious why the kind of vertical integration here of the reader versus the library tool that uses what's read in.
Yeah, so this is a very good question. I can give like a kind of very concrete example of this. So looking, for example, at this dictionary encoding, right? So Dictionary encoding for most types will just basically mean, okay, you have to instantiate that value out of your dictionary into your arrow array or something. But for strings in arrow, you have many representations, and the one Polars uses is a view representation. So you have buffers and you have views into those buffers. And what you actually want to make sure that you do is, if you have a dictionary, you just fill your buffer with all the dictionary values, and then you just put a bunch of views into your array. Like, you don't want to push a new value into your buffers every time. And this is very important that you make sure that you do while you're reading. And this is why you can't really do like you need to make sure that at least you're using some arrow implementation that is based on views, or like that has support for these views. Maybe another one that is like very Polar specific is that, well, our expressions have very different semantics than, for example, the Polars Parquet expression thing might have, right? So converting these expressions is actually quite difficult and not lossless. So one thing we ran into, for example, is that for floating point, you have nans, which, like, nans are a whole headache onto itself. And actually, the way, for example, data fusion handles nans is completely different to the way Polars handles nans, right? And if you would merge them and like just naively pretend that they are the same implementation, you would get kind of you can't do a bunch of optimizations that you would be doing if you just take the parquet from data fusion, for example.
Would that mean that if I wrote a Parquet file via data fusion, that Polars would have to do some conversion under the hood or have to know of the origin in order to properly read it back in?
No. So Parquet, like the really the goal of Parquet is to be, well, we standardize uh, how we write the data and how you can read the data. But then when you start pruning again, you need to, from that standardized way, you need to reason back into what your semantics are.
Mm-hmm.
And that step is very hard if you start using other readers.
Yeah, that makes sense. It's kind of it would be like a great filtering, so to
Yeah,
speak, of, you can't pass through the Polars expression through that
yeah,
filter, so to speak.
yeah.
Um, and this actually leads me into my very final question. So if anybody else has one, feel free to mention it. But my final question for you is, at some point in time, DuckDB decided that Parquet is not enough, and that's likely because they have multiple tables that they're dealing with at any given moment, and so they have their own proprietary file format, their own DB file. Do you ever envision Polars creating its own proprietary format to eke the most amount of speed, like a .polars file in the future?
Um. Well, okay. So I would definitely not say no. Like, one of the major use cases here. So I think DuckDB has their own like kind of IPC equivalent. It's not necessarily like
Mm-hmm.
a Parquet equivalent, but it's more like an IPC equivalent. And one of the major use cases for DuckDB for this is they do out of core. So if you go out of memory, they need to write their data somewhere, and you need to read it as fast as possible again as well. And there's kind of very different characteristics to how you want to balance your read-write performance at that point. And also, since you're the only consumer, you can make it in a completely different way where you can kind of just like zero copy it into your engine, or if you make your file format correct. And Polars is working towards this out of core as well. Like, it is like on our short-term roadmap. And maybe in the beginning we won't have such a format, but as soon as you start getting into like, okay, we have done all the medium hanging fruit of like optimization for this out of core, I think you get quite quickly into, okay, maybe we should start writing our own file format because this can actually change quite a lot. But I think we are not there in the coming, like at least half year, maybe even year to 2 years.
Excellent. Thank you so much for sharing that. I think that's very insightful. Any final questions from our panelists before we adjourn? All right, if there are no other questions, then let's go ahead and wrap up for today. I want to give a huge thank you to Gijs sharing his knowledge with us about the Parquet file and what Polars is going to be doing today, as well as in the future with the Parquet spec. Thank you to our audience for joining us as well, and of course, thank you to our host panelists for joining us. Make sure that you check out our website, that's meetup.doepy.org, for our future sessions. Thank you all again for joining, and I hope to see you next month.